Hey everybody, how's it going? This is OurHouse21, and since it's been so long since I posted a video or any substantial content, I figured that it's about time for me to go ahead and post another quick tip. Okay, that was tongue-in-cheek. If you guys have been paying attention, I've posted a ridiculous number of videos lately, but that's besides the point. Alright, so I was checking out the videos over at, or the latest post over at Bashers United, and I noticed that our friend Lamont just put the most ridiculous, hugest RC motor I've ever seen inside Clockwork Orange, and logged in, I think he did like 114 or 111 miles an hour. But based upon the gearing that he had and the power system he was running, he was expecting more. So he wasn't sure if he was getting a voltage sag problem or if he just didn't have enough space where he just couldn't accelerate to the right speed, or what was going on there. So it hit me, it would be really great for his application if he had a way that he could go in and measure, how much the voltage dipped. And that got me thinking, well, that's the exact reason that I picked up this guy right here, my Telemetry power meter. Now, you guys have seen this thing probably more than you care to lately. Let's see if I can plug it in one-handed. So while I'm talking, so I mean, you saw that I used this to benchmark my bearings for the Volca bearing swap videos, and you see Dizzy sitting here waiting in the background. So the question is, can he use something like this in order to get him the data that he needs in order to see if he's suffering from a voltage sag problem or if there's something else going on? And I'm not doing too well with this, so just hold on one second. Okay, so if you notice with this power meter here, it does tell you, what the voltage is, and also gives a measurement of the max amperage and the minimum voltage, so you can see what your current voltage is and what the sag will be. The problem is this thing is rated for 100 amps, and as you know, with the big dog power systems like Dizzy has now, but what you see in most of the speedrun cars, you're talking about 120 amp speed controller that can actually pull peak loads of over 200 amps. So this little meter, it will be a choke point inside the power system, so you really don't want to have that in line and have all your juice going through this, because you don't want to fry it, and then you don't also want to add additional resistance and slow down or reduce the amount of current that's going to go to your big dog motors. So what can you do? Well, it hit me. I've got my little parallel connector here. So if anyone who has a power meter, just simply plug this up in parallel with the battery, not in line. So basically, if you plugged in the connector here and then plugged in to the car on one side, and then you plugged into the meter on an open side, you will be getting a measurement of what the what the voltage is going through the system, but you don't have to worry about the current because there's no actual current flowing down the line. So this is a dead end. So this will let you monitor the voltage, so you can get your voltage sag number, but you don't have to worry about frying your power meter or adding an additional load in the power system. So that's great. Problem is, at least for my situation, my little parallel wire, I've got the long set of connectors. What I would really need for this is this right here is a male connection going to the power meter, so this acts just like the ESC. These right here on the batteries are female connectors. So what I really need is a connector that has a female and another female and then the male. Now I could just rig up another one of these parallel connectors, but what fun would that be? Well, actually that would probably be the most simple and straightforward thing to do. Except, in my efforts to build up tons and tons of cars, I managed to amass a little backlog or a supply of Dean's connectors, and I ended up with some extra female ends, just because when you wire up an ESC, typically you buy these Dean connectors in pairs and you only use the male connector, so you end up with these leftover female edges. So what I've got set up here is just, if I can focus, So what we have here, is actually a set of two females, which I have set up on my little helping hands, that I'm just going to go ahead and directly solder the two contacts together. So I have a positive to positive and negative to negative. Connect those two bad boys, and then I will have a male to male adapter. So I could then plug in this power meter to one end and allow me to put this guy in parallel. So I can do my power measurements, or actually do my voltage measurements, and not have to worry about destroying anything. So I'm gonna go ahead and pause, and I've got my soldering iron right here ready to go. I'm just gonna go ahead and solder these guys up, and then I'll be right back. Okay guys, I'm back, and the connection is all soldered up now. So just so you see here, I just went ahead and if it focuses, come on, you can do it, little guy. All right, so I went ahead and soldered this guy up here, and the next step will just be to insulate this. There it is, it's finally in focus. So what I figure is I've got some of my liquid tape, so I'll just go ahead and put some of that one in the middle. The nice thing about this kind of wiring here is that I really don't need to be hugely concerned about the absolute quality of this connection, because no current is going to flow through here, because the end here is going to be left open. So this will just be sensing voltage. No current will flow through, so it'll be able to watch the voltage dip, but it's going to show, like I said, no current draw. So there shouldn't be any issue with this heating up or having any issues. So just going to throw some liquid tape on this, make it secure, and actually, let's just go ahead. I know I'm not going to be able to do this one-handed, but I mean, you get the idea. I'll be able to plug this in to my little parallel cable, and then I'll be able to have this in line, run it in the car, so I can get in-run voltage data. It's not going to give me current data, but you know, like I said from previous videos, if you have characterized your motor using your Castle speed controller, like I've outlined in my Castle Hidden Secrets video, then you know exactly what the kV rating of the motor is, and you know what your gears are, and so you can directly by yourself, calculate it, or you can go to online calculator. And I'll go ahead and I'll post a link to a really good online RC calculator site. And actually, I need to just do a video talking about the site. It's got lots of tools where you can go in and you can calculate all sorts of parameters about your cars. But anyway, if you know what your voltages are, just like what I did in the bearing video, you can multiply by your kV rating, and then that will tell you the RPM that your car went to. So you can directly measure how fast your car went from the voltage, at least from an RPM standpoint. You do conversions and you have your actual mile an hour. So you can compare that reading to your GPS. The speed your wheels go to is directly a function of what the battery voltage is. So if you didn't hit your top speed and your voltage is still high, that says that you just didn't get enough run space. If you see on your voltage that your voltage dipped way low, then that means that you have voltage sag, and that's your battery basically let you down. So that's a good spot check, so you can see where the weak link in your system is. Is it your batteries, or is it your actual run? Because if it's your run, then what that really means is that you're overgeared. So you need to go down to a lower set of gears so that you can accelerate up to your speed in a shorter amount of time. The problem, of course, with that is that if you set your gears too low, then you're going to accelerate really fast to a slow speed. So it's a balancing act. But I mean, there's also some other stuff that's going on there too. Because if you do find yourself overgeared, it's not necessarily the end of the world if you have a really torquey motor like Lamont does, because there's actually limitations on how fast the motor will spin based upon how much power the power system is putting out, and that's pretty much independent of what your gearing is. And that's the situation I was running into with Slade and all my 70-mile-an-hour fail videos. And I'm actually gonna rig up a little experiment to show you guys all about that. So, okay, this quick tip is getting a little long, so I'm going to go ahead and wrap it up right now. But, you know, I probably got another 2 or 3 videos worth of talking about, you know, just the relationships between voltage and current, and I'll just allude to what I'm going to be talking about here. Because the thing about a brushless power system is that it's not like a brushed power system where you just put a voltage on and then it just spins up. The speed controller is actually an advanced processor, and it measures the position of the internals of your motor at all times. So based upon the signals that are coming back on the wires, it knows if your motor is keeping up with the speed that it's trying to spin it. And if you run out of power, so let's say you're geared for 100 miles an hour, but you only have enough power to get you to 70 miles an hour, it will detect when it gets to that point where it doesn't have enough power to make the motor turn any faster, and it will stop there. And that's a protection measure so it doesn't overload its internals. So, like I said, if you're geared for 200 miles an hour, but you only have enough torque or enough power through your power system with your current and everything to get you to 40, then it's going to take you to 40, and it's not going to take you any further. So, and I'll explain how it does that and why it does that in a subsequent video. So I hope you guys find this interesting. Lamont in particular, I hope this is useful to you. If I see you running with a Trinity power meter or something like that, I'll know what happened. All right, but you guys remember to like, comment, and subscribe. Let me know if you think this video was useful or interesting information. Remember to check me out on Facebook. Feel free to comment or just throw out ideas, or just shoot the breeze. All right, guys, as always, remember the mantra: fly, fix, fly, break it, fix it, and do it all over again. And I'll be looking forward to seeing all you guys out there, because the weather is starting to get warm, and I have a feeling I'm going to be seeing a lot of run videos, and very soon I hope to be doing some of those too. All right, guys, take care. Peace.